Hello and welcome to my video on my Peaceable Queens solver. So I was inspired to make this because of this YouTube video. Numberphile is a YouTube channel about mathematics, and they mentioned this was an open problem and that the world records, current world records, are stored here in the online encyclopedia of integer sequences. However, they haven't been proven to be the best solutions possible. And so I'd originally written this in order to try and break those world records. And my code ran for days and days and it found nothing. So because I didn't want to put code on GitHub that would just run and run and run and not do anything, I modified it. So now this software tries to match the world record. And so you give it a board size and it will throw on a number of queens that it knows has been found to fit, and then it will try to arrange them in such a way that there will be no conflicts. So let's have a look at it doing that. If I clean it up so that it looks like the way it is if you were to clone it yourself, then now we can do make run, and the make file has a default value of 11 after it's done compiling it. So it's going to run an 11 by 11 board, and it's going to look and look and look. And I just put the timer there because on a larger board, particularly the 30 by 30, it takes a while, and I wanted the user to have some feedback to know that like it is working. It's doing something. So anyways, yeah, here, it found a solution. However, it's the nature of the simulated annealing algorithm, it's the nature of all local search algorithms, that they're not guaranteed to find an optimal solution. They might get stuck in a local optimum. Well, actually, yeah, that is the major pitfall. Simulated annealing tries to avoid that by doing some random hopping around, and it gets closer and closer to a strict hill climbing algorithm the longer it goes on. However, well, actually, you know what? I can just scroll to show you. There was, yeah, here we go. It didn't find an optimal solution there. And if you want to run this, if you want to run it yourself, it's pretty easy. You can just type in a number in between 3 and 30 inclusive. Hey, look, trivial solution, tiny board. Or we can do something larger, like 18. And now it's slower. And in my defense, the problem itself is quadratic. The number of conflicts that are possible, it just grows exponentially as the board width slash height grows. If you double the width of the board, you quadruple the number of cells within it, and you make the number of potential conflicts much larger as well. Ta-da! Found a solution. So all the code is commented if you want to check it out. That's basically it. Have a good one.